Alright, it's time for another math easy solution. Here to discuss a quick video on basically further on derivatives of logarithmic functions, but now look at an example to simplify derivative using log rules. First, I'm going to go recap on log rules, or what log functions are. Basically, if you have a to the power of y equals x, where a is a constant, you want to solve for y. This is basically getting the inverse, and you would write it as y equals log base a of x. And if a equals the number e, then replace a with e to the y equals x, and then basically y equals log base e of x, and this equals to ln of x, or natural log, because it's used a lot. Yeah, and basically the derivative of log base a of x would equal to 1 divided by x times ln of a, but the derivative of ln of x basically is just going to be 1 divided by x times ln e, and this equals to 1. So equals 1 divided by x, and that's why e is used a lot. So if you want to learn more about logs, natural logs, number e, and the log rules, see the related videos in the video links below, as well as any other video, and as well as any other topic that I cover here, but not in depth. Everything in the related videos I do in depth. Basically, the example I want to go over is this one right here, y equals ln x plus 1 divided by squared x minus 2. So this looks really complex, and I'll solve it first the hard way, which is just directly finding the derivative, and then I'll do it the second way using log rules, which is just greatly simplified. This just to show you how much work you save by applying the log rules, kind of like this ln e, which is equal to 1. So basically, the derivative of this would equal y prime equals 2. Applying this rule, derivative of ln x is 1 over x. So this one is, we do 1 divided by this whole thing here, which is x plus 1 divided by square root x minus 2. So we have this. And now we have to multiply it by the product. not the product. I mean quotient rule, or using chain rule, you need to take derivative of this inner function, but we have to use the quotient rule. It simplifies it. And we know quotient rule is if you have f equals y equals f divided by g, then the derivative would equal to f prime g minus f g prime, all divided by g squared. So we apply that. I'll just put this in and cover that up. So if we apply that, we'll get derivative of x plus 1, which is our f, which is going to be 1. So I'll put this aside here, and then multiply the bottom g, which is square root x minus 2. And now we have to subtract, well, x plus 1, which is our f. And now derivative of this, the derivative of square root x minus 2, which is going to be 1 divided by 2 square root x minus 2. And I'll just do a side note of getting the derivative of that. If you have basically d over dx of square root x minus 2, this equals 2. You could rewrite it as d over dx x minus 2 to the power of 1 over 2. And now this would be, using power rule, bring the 1 over 2 down, and then x minus 2, this can be subtract this by 1, will be 1 over negative 1 over 2, and it is the same thing as writing square root x minus 2. So that's another thing. I'll put it in brackets or cloud here, circle it, and that's this part right here. And then we all divide this by the g squared, which is basically x minus 2, because square root and then squared, they'll cancel out, so we'll be left with that. So we have this, and now we could simplify this further to make it look better. Just this would be on, this is the same thing as flipping it over, and we'll have square root x minus 2 divided by x plus 1. So we have that, and this multiplies it by, well, we could have, on this one, we could multiply by the common denominator, which is 2 square root x minus 2, so we could add them up. So we'll get basically 2 times square root x minus 2, and then squared, because we're multiplying it out, the top has this in there, and then all this is divided by, this is all divided by 2 square root x minus 2, and then subtract this by this one right here. So we just do that so we can subtract by x plus 1, but we're subtracting, so minus x minus 1, and this is all divided by, we already have this x minus 2. So as you can see, it's pretty complex. It's pretty complicated, this derivative that we're doing. And then if you basically look at this part right here would cancel with this. Yeah, so those would cancel right there, and then this would be equal to basically, this would, write this down, be 2 times, well, the square roots cancel, x minus 2 minus x minus 1, all divided by 2, So this is there's gonna be this is the 2 there. We'll have this x plus 1, and we'll have this x minus 2 right there. So we have this right here, then simplifies further by this would be 2x minus 4. So we'll have 2x minus 4 minus x minus 5, all divided by 2x plus 1, x minus 2. The x will have 1x, and then, I mean, this is a 1 right here, not a 5. So minus that, we'll get finally x minus 5 over 2x plus 1. And then this is x minus 2. Yeah, and basically this would be our final answer right there. But now, so as you can see, this is pretty complicated what we did here, this calculation. But now if we use the second solution for this using log rules, basically, yeah, so basically write this down here. Solution 2, the derivative, or first we just simplify this before we take derivative. So y this is also equal to, well, using ln or log rules, this is the same thing as writing it as at ln x plus 1, and then subtracting, because this is a division, so we have to subtract by ln of square root x minus 2. But this one equals to, well, yeah, so this is also equal to ln x. I'll just simplify this further. This is the same thing as writing ln x minus 2 to the power of 1 over 2. And now using another log rule, this would go down if you have a power. So we'll have ln x plus 1 minus 1 over 2 ln x minus 2. So this is what we have, and now we can take derivative. So y prime would just equal to, well, 1 divided by x plus 1, and then subtracted by, well, this is going to be 1 over 2, and then flip this down, so x minus 2. And there you go, that's our answer. This is the exact same thing as, yeah, this is the exact same thing as this one right here. If we just use a common denominator, you could even just test that out yourself. So multiply this side by 2x minus 2. So we'll get 2x minus 2, and then subtract this by, well, this side's going to be x minus, or yeah, x minus 1 or x plus 1 here, but there's a negative, so x minus 1, and then this is going to be 2x minus 2x plus 1. And actually, no, this is, I forgot to put the brackets here. So now this is going to be the exact same thing, 2x minus 2 minus x. That's just this one right here. Or that's this part right here. Then when you simplify, you'll get this answer right there. So this is the exact same thing, and you'll end up getting x minus 5 divided by 2x plus 1 and x minus 2 right there. So this one, as you can see, this took a few seconds versus took several minutes, and it's just a lot of stuff, and you might make a mistake because there's just so much algebra. And we in this one we even avoided the quotient rule. And now as a check of the work, if we basically graph this out, this one is our y, this is our derivative. As you can see, I just plug those in with the Google Graphing Calculator. But as you can see, as this is near 2, whereas there's an asymptote, because you're doing a square root of x minus 2, it can't be negative, so everything has to be to the right of this 2. That's why this is vertical line. So as you're close to it, it's going down here. As you go farther away, it's going down. But then as you're close to it, you'll have a negative infinity slope right here of going straight down. And that is our slope right here, so it makes sense. And then as it goes down here, this derivative gets 0 at the horizontal tangent, and then it starts to slowly increase, and this derivative slowly increases as well. Anyway, that's just a quick check of the work, but I just really wanted to illustrate this log rules, which is pretty amazing. You could even skip these steps and just write it straight to this one here once you get the hang of the log rules. Anyways, that's all for today. Hopefully you'll learn from this. Remember to watch the related videos in the video links below, as well as if you want to download these exact notes, you download them in the Dropbox link below. And thanks for watching, and stay tuned for another Math Easy Solution.